Welcome to The Explainer. Today, we're exploring an absolutely massive foundational shift in how we handle data architecture. We usually just think of databases as these places where we update the current state of things, right? Just overwrite the old with the new. But to really grasp the paradigm shift we're talking about today, we're going to look at data through the lens of a simple financial ledger.
So picture this. You log into your bank app, and all you see is a single number, your current balance. That's it. There's no record of your deposits, no history of that overpriced coffee you bought yesterday, just the final tally. What if the bank literally deleted all your history the second your balance changed? Honestly, that sounds pretty terrifying, right? Yet, this destructive overwriting of old data is exactly how traditional mutable databases operate. They basically act like a giant whiteboard eraser, constantly wiping out the past just to write the present.
So here's our roadmap for today. First, we'll cover the event sourcing paradigm, then history and rebuilding state. After that, we'll dive into the CQRS architecture, weigh the benefits and trade-offs, and finally, look at the future of data.
All right, part 1. The event sourcing paradigm, beyond the eraser. Okay, so event sourcing fundamentally changes our entire approach. It basically means building your application logic on a foundation of immutable events, which are written to an append-only log. Think about it. Accountants have literally been doing this for centuries with financial bookkeeping. When a transaction happens, they don't just take an eraser to the old balance, they record the change as an irreversible fact in an append-only ledger. Event sourcing is just bringing this exact same time-tested principle to our software architectures.
Putting these two concepts head-to-head, it's a pretty stark contrast. On one side, you have mutable state, the eraser. It updates in place, meaning it overwrites old data and totally loses the history of how we even got there. On the flip side, we have immutable events, the ledger. It's strictly append-only, meaning it retains a perfect historical record. By treating a database like an eraser, we lose so much valuable user intent. But with an append-only ledger, we preserve the entire, unedited story of every single order, transaction, or user action.
Moving on to Section 2, History and Rebuilding State, Deriving the Present. Now, you might be wondering, if we're never actually overwriting data, how on earth do we know the current state of things? Because, let's be real, an event log all by itself isn't what users want to look at. They want to see their current shopping cart, not the entire history of everything they've ever added and removed. So we have to derive the present. The mechanical steps here are pretty straightforward. First, we just scan that append-only event log right from the beginning. Second, we process each event deterministically. And third, we output the derived current application state. Essentially, by replaying those raw historical events, we perfectly reconstruct the exact current bank balance or cart contents.
This actually brings us to a brilliantly elegant mathematical metaphor behind data. For those of you who are mathematically inclined, you can think of the current application state as the integral of an event stream over time. And conversely, the stream of changes, that's the derivative of the state. Mutable state and an append-only log of immutable events aren't actually at odds, they're literally just two sides of the exact same coin.
Section 3. The CQRS architecture, bridging the gap.
So here's the next big hurdle. If all our data is locked up in this massive, ever-growing historical log, how do we actually query it efficiently without replaying it every single time a user hits refresh? Enter CQRS, or Command Query Responsibility Segregation. This is the vital architectural bridge that solves our query problem. CQRS completely divorces the write mechanism from the read mechanism. It separates the data structure used for writing, which we call commands, from the data structure used for reading, the queries. What's super interesting here is the separation between the eager pre-computation happening on the write path and the on-demand querying on the read path. The derived dataset, like a fast search index or a materialized view, is the exact boundary where the write path and the read path finally meet. Basically, you do all the heavy lifting of processing events into a read-friendly format eagerly behind the scenes, so you save all that computational effort when the user actually makes a query.
Let's break down exactly how these models differ. The write model is structured strictly as an append-only event log. It is completely optimized to maximize write throughput, and it acts as the absolute authoritative source of truth. On the other hand, the read model is structured as materialized views or projections. It's highly denormalized and optimized specifically for blazing fast querying. And remember, it is entirely derived from that write model.
All right, Section 4, Benefits and Trade-offs, Weighing the Costs.
So why do engineers choose to adopt this architecture despite all the obvious complexities? Well, the benefits of immutability are just massive. For starters, you get flawless auditability, which is absolutely crucial for any kind of financial system. You also unlock literal time travel debugging. You can reproduce the exact state of the system at any prior moment in time. If you accidentally deploy some buggy code, recovery is a breeze because you haven't destroyed any good data. You literally just fix the code and reprocess the log. And perhaps most importantly, you capture highly nuanced user intent. If a user adds an item to their cart and then decides to remove it, a traditional overriding database destroys that analytical goldmine. Event sourcing captures that abandoned action perfectly.
But, of course, there's no such thing as a free lunch in software architecture. We have to contrast the immediate but kind of fragile nature of traditional updates with the robust but delayed nature of event-derived views. Traditional databases use synchronous updates. They happen immediately. But if you're coordinating across multiple systems, a single failure can cascade and blow up the whole transaction. Event-derived systems decouple all of this. They are incredibly robust because they process asynchronously, but this does introduce eventual consistency, meaning a user might briefly see slightly outdated information until the read view catches up with the event log.
We definitely have to look at these architectural trade-offs honestly. That asynchronous lag we just talked about, it creates the classic reading your own rights problem, where a user updates their profile but doesn't immediately see the change. Then there's a harsh reality of an append-only log. The data grows literally forever. Managing those storage limits becomes a very real engineering challenge. Plus, the complexity of evolving your schemas and versioning decades-old events requires some incredibly careful planning. You'll almost certainly have to rely on log compaction strategies, like only retaining the most recent event for a given key, just to keep the whole shebang manageable.
And finally, Section 5. The future of data. Streams everywhere.
As we wrap up this explainer, you really start to see how treating databases as streams of events fundamentally shifts how we think about application development. The crucial aha moment is this. Once you fully embrace event sourcing, you realize that traditional, mutable databases aren't actually the final source of truth. They're basically just temporary caches. They just represent the latest snapshot of a much deeper, hidden log of events. The real truth? It's the log itself. The database is really just a convenient, optimized caching of whatever the latest values happen to be.
Which leaves us with a really fascinating thought to end on. If databases are ultimately just streams of events, could the future of our applications be entirely end-to-end streams? Imagine a world where we completely abandon static request-response queries. Instead of constantly pulling data, what if our user interfaces and mobile screens simply subscribe to a continuous flow of state changes pushed right to us in real time? It's a real game changer that completely reimagines how we interact with information.